When graphing kinematics graphs of position, velocity, and acceleration with time, there are certain patterns that emerge that are useful to know about. We saw from class in the moving man demonstration, the interactive web Java application, that if we ever set the acceleration to be a negative number, then the position graph at that same moment in time, the position graph was going to be concave down. Now, depending on starting velocity, it could be concave down like this, or we might have only had the left half, or perhaps we would only have the right half. The point is, if acceleration is negative, the position graph is concave down. On the other hand, when the acceleration graph is positive, then the position graph will always be concave up. It could be concave up a full parabola, could be concave up with just the left half or just the right half. It could be down here, right? I mean, it doesn't really matter where the parabola is. Same thing over here, right? This parabola could be here, perhaps. The point is, negative acceleration, concave down parabola, positive acceleration, concave up parabola for the position graph. Now, the way that ties into and relates to the velocity graphs are that if the velocity starts at 0, with positive velocities, let's say, then the position has to start on the flat section of the parabola. So this one would be positive velocities, so that's going to be a concave up. Okay, this velocity graph leads to a positive acceleration graph. So that's concave up because this starts at 0. I get the half parabola starting at 0. If the velocity had started at, say, a positive number and decreased like this, that would lead to an acceleration graph that was negative, and so the position graph for that would have to be concave down, and it would start at something not 0. So that's going to have to look like maybe this, okay? Concave down, because it's opening down, the rest of the parabola would come around this direction. Concave down, starting at a not 0 slope and heading for a 0 slope if I think about the tangent lines.